before the official start time. Okay. All right. You mean A star? Yeah, yeah, we did. Yep. Mm. No, I don't think it's needed unless you guys have a specific question. Yeah. Yeah, so if you guys, okay, so I'm gonna start the lecture. The recorder has started. So if you have any questions about Dijkstra's algorithm or the A star algorithm, like you come up with a very specific graph, okay, with all the edges and the distances between the edges, and you go like, I'm not really sure how this is going to work out because it looks kind of tricky. We can always go over some of those examples. Okay, so if you come up with your own example, and you go like, I'm not really sure whether A star or Dijkstra's algorithm can handle that. We can do those in the class. Okay. All right. So what we'll do today is we're going to start with something that is not related to discrete structure, and instead it has to do with AI. Okay, so what I'll do, I'm, you I think that is actually more important in some way than the actual material for the class. So I am looking for the article that I was talking about. So PBS. Okay, that should find it. There we go. Just found it. Okay, so I will just put this into your view over here. And where did it go? Oh, it didn't work. Okay, let me try it one more time because I'm just dragging a tab over to this tab over here. All right. So if you just look for the question or the title, which is how artificial intelligence is reshaping college for students and professors, it will bring you to this rather boring looking PBS page. It is a news report, okay, from different perspectives of how artificial intelligence is reshaping, as the title says. Okay, for the most part, I don't care about that. Okay, because what I really care is how is that going to change the way you work. That is a much bigger question. Okay, then just going through college and stuff like that. A good half about this entire video talks about academic integrity, where a lot of people use AI to turn in homework assignments for their writing classes and even for programming. I mean, especially for programming. Okay, I can guarantee you already everything that you need to do in programming for homework assignments, the AI can do it. Not a problem. Okay, so the question is, what are you going to do about that? I mean, do you understand the question of why I ask what are you going to do about it? Because if AI can do all your homework, by the time you graduate from a 4-year university, and that is all you learn, okay? You learn everything that AI can do already. Then the question is, how are you going to convince someone to hire you? Okay, so that's, I'm going to open up the floor, let you guys kind of explore some of the answers. But there's no productivity to. I mean, the AI can do everything that you can, making if we make that assumption. So the first question is that a valid assumption? Yes. Okay, so how do you demonstrate critical thinking? Mm-hmm. 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 I see. Okay. So in physics, you have two constants, right? So you have constant current or you have constant voltage, depending on what you're analyzing. Yeah. Hmm. Okay. 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 So, okay. Okay. So the limitations of AI, okay, so I just had this conversation with two particular individual over the weekend, and I think both of them have an IQ that is 30 points, higher than mine because I can barely touch, what they're talking about. I catch glimpses of their concepts, okay? But that means, they're about 30 points away from me. So these are people who are working in industry already. One is a scientist working for Lawrence Livermore National Lab. The other one has his own company, but he also has a lot of interesting projects on the side. Let's just say that he was one of the original people who came up with DevOps. If you have not heard about that term, you can look it up. It is a very important concept, even from the perspective of software development or software engineer. So the term is DevOps, huh? Yeah. So he came up with basically DevOps, like decades ago, using just Make, as a utility program. But he was able to make it work for, server administration and deployment of, software and so on. So anyway, it suffices to say that both of these individuals are really smart. And one particular individual, when I told him that I'm teaching CISP 300, and then his comment was, you know, um, have you told your student that there's no future for them? That was his comment. He's the kind of straight shooter, that you really do not want to know, but you know that what they say actually has some truth in it. So that's basically what he said. Okay. So my question is, what do you think is going to be in your future? So that's one thing. The second thing, which is even more interesting and disturbing in a way, was, he said with some proofs that what we think about the limitation of AI is not exactly the limitation. In other words, the current generation of AI, which is Gemini 3.0, um, ChatGPT 5.1, and so on, they are actually more capable than we think they are. Okay, so you told me about the story of circuit analysis, and it seemed to be struggling a little bit with it. So I think a lot of that is has to do with how we prompt. Okay, how much information did you give it in the first place? How did you give that information, and how did you write about all that information to begin with? Um, so he did an experiment. Okay, so he did an experiment with his work stuff, which is kind of complex problem solving, and he tried different techniques of prompting the AI, and he was able to get the AI to think in a creative way compared to what we think AI cannot do. So so he has a hypothesis about why we think AI cannot do as much as it actually can. The answer is disturbing. Okay, it has to do with the AI is assuming the end user is a neurotypical person. So if you have not heard about the term neurotypical versus neurodivergent, I encourage you to look into it a little bit, okay? And you can you can look up those terms. So you can ask, what is a neurotypical person, and it will give you a quick answer, okay? Basically, if you think about the capability of a person in terms of abstract thinking, logical thinking, analysis, the ability to deal with abstraction, and so on and so forth, and you make it into a multidimensional space. Well, most people, would cluster, as a kind of like a little circle or ellipsoid, and it would just be a cluster. So that would be neurotypical. And then the rest of the population are neurodivergent, which means they occupy that space in some random spaces. Okay, some may have extreme analytical skills, but when it comes to relational skill, like how do they talk to other people, it's like no, they fall flat on their face. Okay, so that's what neurotypical versus neurodivergent is. So the reason why I brought this up has to do with what do you think is the majority of people who contribute the content that we use to train LLMs, large language models. neurotypical or neurodivergent? Actually, it is mostly neuro. Well, by the time it is published, it is no longer catered for neurodivergent people. So it might be written by neurodivergent people, but the target audience would be neurotypical because the the main audience is neurotypical. So that means that when the LLM is trained, it is trained to communicate with, if you don't tell it otherwise, it is trained and by default, it is talking to neurotypical people. Okay. So as a result, if you don't say anything, the output of an LLM is quote unquote, according to this guy, it is watering down the answer for the neurotypical person. So if you prompt it differently, you can trigger it to give you an answer for neurodivergent people. So that's according to my buddy, okay, who did some experiments, with prompting. So I did some other experiments, okay. I did some experiment, but I didn't see it as an experiment, but this is my experience. So if you have a long conversation with AI, it would start to use your way of communication to respond back. Now, I'm not sure how much conversation you guys have had with AI. I probably have an unhealthy amount of conversation with ChatGPT and Gemini. Okay, and in long single conversations. So I'm not talking about like 2,000 tiny little conversations, like what is the best restaurant in Sacramento? Okay, not talking about that. Okay, we're talking about long conversations. So I found out that AI can copy the way that I talk, the way that I write, because when I write things not related to technical stuff like what we are doing here, I use a lot of metaphors. Okay, I use metaphorical expression. Okay, so you guys might think, oh, tech is using metaphors like Star Trek or Star Wars, stuff like that. Well, I do that too. Okay, but I also use the physics of p-n junction. I also use astrophysics, like the physics of a black hole, and many other really, really rarely, people don't consider those as metaphors, but I do. So the AI bounces back its own answers, its own responses, using metaphors of the same range of knowledge. So if you think about the use of metaphors, it is actually a form of creativity because it is relating to different things that are usually not comparable. Okay, and I'm not talking about the relation thing comparable. I'm not talking about those two things most people do not associate, right? So by associating things that are typically not associated, the AI is actually demonstrating a certain level and a certain kind of creativity. Sometimes I look at the metaphors of the AI and I go like, wow, that is something that even I could not think of. Because I would start with a metaphor and then the AI would identify the metaphor and go like, oh, this works in this way and this way and this way and this way too. In terms of comparing the two things. And some of those surprise me. So if you think about AI like an iceberg, okay, how much of an iceberg is above water? Approximately 1/10, okay, about 10%. I think we are only seeing about 3% ish, okay, of what AI can actually do, and that's with the AI that we have today. So we are not even talking about AI in 2 years when you graduate from a 4-year university. Okay, so I hope you guys understand the trajectory here. Okay, am I getting that point across? Do you have any questions about what point I'm trying to get across? Okay, so now the question is, what do you do with AI? One, use it. Okay, so I may be one of the few people who would recommend people to use AI on this campus, but I think it is essential that you use it. Okay, so now the next question is, how do you use it? Okay, so let's just say that you get a last final homework assignment from Iraj and you have to implement Dijkstra's algorithm. and you're kind of wondering how am I going to supposed to implement Dijkstra's algorithm, I can give you the prompt already. Okay, so don't even bother to make your own prompt because I can do it for you. I can say, implement Dijkstra's algorithm in C++, um, not using the template class set. Um, and you can give it some additional requirements. Okay, so no set, as a template class, but you can say you can use heaps or whatever. Okay, so just just that as a prompt. Okay, and we'll see what happens. So this is not the right way, by the way. Okay, to use AI because I'm showing you that it can do this already. All right, polar chart. Okay, so here's the code. So let's see whether it compiles or not. Okay, you know, the only thing I did not specify is how to input the graph and how to output the graph when it's done. So that part I did not specify. So we can probably look at the code here and figure out how it's doing it. So it's hard coding the graph here. Okay, we can push. Um, it's using the push operations to establish the adjacency, which is basically our edges and so on. And then the main algorithm is Dijkstra, and Dijkstra is implemented in this particular function, here. So we'll give it a try, okay, just to see whether it is even compiling or not, okay, because some people may say, oh, it's not even going to compile. We don't have a problem here. I would probably disagree with that. Okay, so there we go. Cat to Dijkstra's, okay, .cpp, because it's C++. Paste the whole program in. There we go. G++ dash G dash O Dijkstra, Dijkstra.cpp. Compile just fine. And then we'll try to run it. Okay. Oops. There's no K. Ah, come on. Get rid of the K. So it gave us a vertex and a distance from the source, and I think that is the path. I cannot be 100% sure. But you can also specify that it outputs the path as an actual path, and also to give you the v, the set of all the vertices, the set of all the edges, and so on. You can just refine the prompt so it can do all of those. So that means this is one way to use AI. So if this is not the right way to use AI, what is the right way to use AI? Because I want you to use it because you need to understand the tool. You need to understand what it can do, what it cannot do, and how to get it to do more work. So, how do you use AI in the setting of a college? Okay. hmm Okay. So, some people ask me, or someone in this class asked me a little bit earlier, what is this? Okay. So, this is the instruction for a Gemini gem. Okay. In order to um, get the AI to become a tutor, instead of giving you a straight up answer, it would actually give you, instructions. It will help you step by step and make sure that you understand all the dependent concept first before you try to understand a more complex concept. So I'll give you an example. Let's just say that concept A depends on concept C and concept B. Concept B in return depends on concept D and E. Concept C depends on concepts, F and G. Okay, so what with this prompt, it will assess first whether you understand where you stand, and then it will say, okay, I can see that you understand concepts up to this point, and then it will help you build your concept, understanding from that point on. And I think that is something that is really super duper important because when you get to a 4-year university, um, being able to study on your own is really important. Depending on which university, you may or may not be able to find the professors. The best you can find would be the teaching assistants. So those are usually just graduate students, who are starving and they need a salary, then they just kind of do the TA job as a way to make a living. Is that okay? All right. So for this class, okay, if you read all the material, so let's just say that you read the Dijkstra's algorithms, okay, so I can go to point that out. All right, so you read this particular um, section or module, and you go like, okay, I can sort of understand some of this, but not really the entire thing. So what you can do, okay, is to make a gem. You can make a Gemini gem. Does everybody know what is a gem? GEM. It's not a saved conversation, but it's close. Okay, so you're pretty close. So I can demonstrate that concept here in this class. So I will go to explore gems. Okay, you can do the same. By the way, you all have access to Gemini now, thanks to the Chancellor's office. And you click on start a new gem, and then you can say tax, personal, TA, or CISP 440. Okay, and then you just say that this is a teaching assistant to help me understand concepts in CISP 440. This part is not important. Okay, so you can type whatever you want, with this part. This part is important. So the instructions sounds really simple, right? But it really is actually a very complicated concept. In other words, this instruction here is repeated for every single prompt that you put into the system. It means it will not roll out of the context window. It is always be going to be there. So now, if you want the AI just to give you the answer, you can just ignore this part entirely. On the other hand, if you want the AI to help you understand the concepts in a step-by-step manner, what you can do is to take this instruction here, and I can make this available through the announcement. So you put this over here. Okay, there we go. And then you scroll down a little bit more. Now you can upload files or link to a Google Doc that you have already created in Google Drive, okay, which I recommend because if you have a live document, the gem would actually use the latest version of the document automatically, and you don't have to re-upload stuff, okay? So now I'm going to go back to my module, okay, and I go to view the source document, which is at the bottom of the whole thing. I'm going to download this. Okay, so I'm going to call this graph.md. MD stands for Markdown, which is a specific format method to format content. And then I go back to my gem. Okay, and then I scroll back down here and then add knowledge. So you can upload or associate up to 10 files. Each one can be up to 100 megabytes. So most of you are going to go like, oh, 100 megabytes, that's not a whole lot. Well, if you have 100 megabytes of text only content, that is huge. Okay. I can probably combine all the reading material across all the classes that I teach, and it probably adds up to 1 megabyte. So 100 megabyte is a huge. Okay. But you only have 10 files. So that means if you have multiple modules that you want to include, you need to concatenate all of those modules into one. Okay. So in this case, because the concept of a set is well known to Gemini, so it won't have a problem understanding that. So just this particular module by itself is going to be sufficient. So I'm going to upload the file. Okay, graph.md. Click open, and this is its upload. And I'm going to double check the instruction here, okay, just to make sure that it is correct. And at some point, I did some editing, and it is okay. There we go. This is a Grammarly. Okay, I also have Grammarly running. It is helpful. Okay, it fixes some grammatical mistakes. So I'm gonna you can also use Gemini to rewrite the instructions. It can rewrite the instructions for itself. It reads what you have to say, and it will try to optimize it. Okay, so but I'm not going to do that. All right. So let me see if I can. Okay, so that's probably all we need to do. Click save, and then we can open up a conversation now. So I'm going to say start chat. So we'll give it the example for as a we'll use your homework assignment as an example. Okay, so that's what we're going to do. So we go back to the homework assignment that's due today. Was Yep. All right, so we're going to go to that's Dijkstra's algorithm. Okay, there we go. So with this one, it's a little bit harder, because of how the graph is described. So what you might need to do is to kind of describe this, in text a little bit more. So that's what I'll do. I'm gonna go through the trouble to translate everything to a format that is easier to read. So let me start mousepad on the side so I can just kind of copy all that stuff here. So I'm gonna stash this over here and I'll retype everything, in the description. So we'll say v equals to the set 1, 2, 3, 4, 5, 6, and the set of edges would be 4, 2, 3, 2, 3, 4, 5, 4, 5, 3, 6, 1. Hmm? I don't know whether it can process a picture and do the OCR, so I'm just, being safe here just to make sure that we don't miss any of this part here. Yeah, maybe. But then this one is hard to extract too because it doesn't show the entire thing. So let me see how am I gonna do this. So I can cheat a little bit because I can go to the edit mode. You cannot get into the edit mode. So we'll go to the edit mode, edit equation. This is the distance function, and we'll put that in dollar signs because it's in LaTeX format. So it has to be enclosed by the dollar sign. And then finally, we have to indicate, where are the destinations. So the destinations are 2 and 1. So we can specify that in here too. The destinations um, are vertex, what again? Can't remember. 1 and 2. Okay. Vertices 1 and 2. All right, so I have just restated the whole problem. Okay, Control C, Control A, Control C from the text editor, and then go back into the Gemini, but this time I'm using the gem called, with my personal TA. So I would go like this. Okay, show me how Dijkstra's algorithm solves this problem. Use the algorithm in the knowledge. Okay, there we go. Click go. Okay, and we'll see what it can do. And I haven't really done this before, so this is kind of the first time that I did this. So we'll see how well it can do it. So what do you think? Do you think you can do it? Or do you think it's just going to come back and say text instruction is totally crappy, I cannot follow the logic? What do you think? We'll see, right? So we'll let the AI do it, and then I'll do it by hand too, just to kind of compare. And the other thing that is also interesting is the show thinking. To ensure we get this right, we need to strictly follow the specific version in graph.md. Let's start with the initialization step. According to the text, we have S as a set of destination vertices. So in this case, it has the two vertices 1 and 2 based on the pseudocode. Da, 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 da. Okay, so now it's asking you. Okay, it's not giving me the entire answer because the instruction said, I need the TA to use scaffolding so that I understand the concepts step by step. So I have to get past this question first. Okay, step one, given the rules above, can you tell me what the initial values for L of 1 through L of 6 should be and which vertices are starting in Q? Okay, so can you answer that question? Okay, so we'll go ahead and answer the question. There's no need to use equations in this case. Q has everything in the destination set, which means it starts with 1, 2 in the set. And then the L values means except for the destinations, which are 1 and 2. So these two have L values of zeros to begin with. And then everything else would have infinity as the initial value. So you don't even have to know how to type LaTeX, to type in the infinity symbol. You can just describe it. LLM are good enough to actually understand a variety of input formats. So now you can say L3 is the same as L of 4, which is the same as L of 5, which is the same as L of 6, and they're all infinity. All right. So the AI is actually using this as a gate, okay? Not so much a gate, but a check to see if I understand the concept, because if I don't, then it's going to correct me here. So do you want me to type in something that is correct, which is what we see here, or do you want me to type in something that is incorrect so that you can see what kind of output it gives you? Okay, so we can make some mistakes here. So let's just say that I forget one of the destinations and I put in something that is not a destination. Okay, so I'm making a few mistakes here. And then this part here is consistent. This is going to be infinity. Oh, okay. To keep the same format, we can just do it like this. And then L of 5 is going to also be a 0 according to this. Okay. So I'm definitely making a intentional mistake here because I want to test whether the AI can give me some feedback and say that, oh, okay, good try, but that's usually what it would do. It's usually more polite than many professors at especially high-end universities, which I will not name. Aha, so it tells me that looks like there's a small mix-up with the destination vertices. In your problem statement, you define the destinations as 1 and 2. However, in your initialization, you treated 5 as a destination instead of 2. So if we stick to 1, 2, how should we correct the sets Q and the L values? So it spots the problem. It doesn't tell you what the problem is, but it phrases the question again back to me to remind me, hey, this is what you told me about the initial or the starting vertices. Maybe you should pay attention to that. So this time I will type in the correct answer. Okay, Q is 1, 2 in the set, and then L of 1 equals to L of 2, which is 0, and then the rest are infinity. So L of 3, L of 4, L of 5, and also L of 6. These are infinity. So infinity, press the enter key, and then we'll see. Orchestrating user engagement. I like that phrase. I should use it more often in my class. I am engaging user inter. All right, so it says it's correct, and now it let me move on. Okay, so iteration one, we must select a vertex V in Q with the smallest L value. Since 1 and 2 both have an L value of 0, we can choose either one. Let's arbitrarily to pick vertex 1. So unlike TAC, which allowed you guys to pick, if there are equal ones, it just chose one for you, and then it gives you the rest. So now it asks you which vertex W connects to 1, and in using this formula, what is the new value for L of W? What vertices are in Q after this update? In other words, it gives you really kind of step-by-step instructions in order to help you understand the material so that you can follow the algorithm. So are we good here or not? So this is strictly a demonstration of how you can utilize AI not only in this class, okay, in your other classes, as long as you can upload your own notes, as long as they're correct, you can still use the same approach. So let me ask you this question. In your other classes, do you have access to anything that you can upload to a gem? Most of the time, yes. Okay, cool. If it is publisher content, I would kind of be careful about that. But as long as you're not distributing your gem to other people, it's probably okay. But you just have to be careful if it is copyrighted material. All right. So with that said, I'm going to kind of do the whole thing by hand. So we'll get rid of this for now. And the time complexity stuff. Okay, we'll get rid of all of these. So do you guys want me to go over the Dijkstra's algorithms answers? Okay, we can do that. All right, so I'll follow my own instructions and use the Google Sheet published in class and use that as a starting point. Okay, so I need to save this again or cancel one or the other. One way or the other. Here we go. Right click, open a new tab. And I kind of need to access this portion here. And I can't see the entire thing unless I zoom out. So that's what I'll do. Okay. Yep, that works. All right, so there we go. All right, so we got that. And this is the template, right? So the first thing I'll do is I'm making a copy of this template. So I'm going to say make a copy. And that's going to be 2025 1201, which is today's date. So if you have a laptop computer, you can go ahead and open the same document as we go. All right. So what we'll do is we are going to label these two with zeros, everything else as infinite. And then the E prime starts off as an empty set. Q starts off as 1, 2. So that's our initial state. And then when we have to pick a vertex out of these two, we can pick either one or two. Since AI decided to use one, I'm going to do the opposite and choose two, just because of my oppositional nature. Okay. If you tell me to use one, I'm going to use the other one. All right. So we are now going to look at all the incoming edges. Okay. So WV is an incoming edge, which means we're looking for everything that ends up at vertex 2. So now what edges are we going to choose? Well, 4 ends up with 2, 3 ends up as 2. Okay, so those are the 2. So maybe 4 and the 3. Okay, doesn't matter what the order is. So let's just say that we assume that we are first considering 4, 2 as an incoming edge to the destination vertex of 2. So now we ask, what is the path from vertex 2 or vertex 4 to a destination? Well, that would just be the distance from 4 to 2, which is here. It has a distance of 1 and is 1 less than infinity because the current known shortest path from vertex 4 to a destination has a length of infinity. Then we go like, yep, it is less than infinity because it is 1. Then we're going to have to add 4, 2 as an edge to E prime. And we also have to add 4 to the set, but I forgot to get 2 out of the set first. So let me do that too. So now we only have 1 left, and then we add 4 to it. So the next one is 3. So we look at the edge 3, 2. Okay, the edge 3, 2 has a distance of 2. So that means I just found a path from vertex 3 to a destination, and the path has a length of 2. So now I have to compare to the length of the shortest path known at this point from vertex 3 to a destination. It's infinity. So I just found the shorter path. So this way I have to update it here. And then we have to say, okay, now we have 4, 2, as well as 3, 2 in E prime. And we also have to remember to add 3 to the set of Q. So that concludes the inner loop. Do we have any questions about this step? Okay. So then we now have 1, 3, and 4 in set Q. So now we look at 1, 3, and 4. And then we look for the one that has the least L value. I think A is going to, vertex 1 is going to be it. So now we choose vertex 1, get it out of the set. And now we look into what edges go to vertex 1. So let's see, 6 goes to 1. Okay, very good. And do we have anything else going to vertex 1? The answer is no. Okay, vertex 6 is the only one. So that's fine. And the vertex 6 to vertex 1 has a distance of 4. So we have just found a path from vertex 6 to a destination with a length of 4. And right now at this point, L of 6 is infinity. So 4 is definitely less than infinity. So we have a bunch of updates here. So we update that to be a 4. And then okay, so I'm starting to copy and paste here. So we're going to add the new edge. The new edge is representing an edge from vertex 6 to a destination. So that would be 6, 1 in this case. And because vertex 6 just had its L value updated, so 6 also has to be added to the set Q. So now we have 3, 4, 6 in the set Q. Do we have any questions at this point? No questions? All right. So then we move on. Out of 3, 4, and 6, which one has the least L value? So we are looking at vertex 3, vertex 4, and vertex 6. So it looks like vertex 4 has the least L value. So that's what we're going to choose. And then we get it out of set Q. And now we look into the incoming edges to vertex 4. So we look up all of this stuff here. 5, ends up at 4. And we also have 3 ending up at 4. I think those are the only two. So we'll work out one at a time. So this one is a little bit more complex now because we know that from vertex 4 to a destination, the shortest path known up to this point has a length of 1. We also know the edge from 5 to 4 has a length of 5. 5 plus, what was it? 5 plus 1 is a 6. So this means that I have now found a path from vertex 5 to a destination with a length of 6. The question is that a shorter path compared to the path that I know up to this point? This tells me that the path, quote unquote path, from vertex 5 to the closest destination has a length of infinity. I just found one with a length of 6, so I think I found a shorter path. So then we update the L value of 5 to 6, which is 1 plus the, uh, it's a 5, sorry. I could not do arithmetics. So 5 to 4, it is 6. Yep, you're correct. It is 6 because uh, from 5 to 4 is a 5, and then from 4 to 2 is a 1. Okay, so that is correct. It is a 6. Then we have to also update all of these. And we have nothing to delete up to this point because we are not updating an L value that is not an infinity. So there's nothing to update to strike out yet. So we are adding vertex 5, 4 or the edge 5, 4 to the set E prime. And we also have to remember to add 5 to the set now. So it becomes 5, 6, 3, 5, and 6 in the set. And then next we consider the edge 3, 4. We know that from vertex 4 to a destination, it has a length of 1. That's the shortest path from vertex 4 to a destination. And then we also know that from 3 to 4, it also has an edge with a distance of 1. 1 plus 1 is a 2. So the question is, did I just find a shorter path from vertex 3 to a destination? The shorter path or the length of the current path is a 3. I just found a path with a length of 2, so I did find a shorter path. So this means I have to update the length of the shortest path from vertex 3 to a destination to a 2. So this time, oops, I updated on the wrong row. It should be here. But this time I do have something to update in E prime. So typically I just add the new edge first, which is 3, 4, and then I have to go back to the old edge coming out of vertex 3 and then strike it out. So Alt Shift 5 is going to do the strikeout. And I also have to add 3 into the set. It's already in the set, but I still have to restate this is the current content of the set, just so that I know that I updated it. Any questions? No questions? Okay. So now I go back to the while loop. Q is not empty. I still got stuff to do. And the question now is between vertex 3, vertex 5, and vertex 6, which one has the least L value? It is vertex 3. Yes. Say that one more time. I'm not sure what you mean. Uh-huh. This is a 3. How did I get the 3? The 3 has to do with the edge 3, 2. Oh, it is 2. Okay, you're correct. Thank you. So that is correct. Yep. So using the correction, there's no update here. Thank you. All right. Okay. So I got this one wrong, and that's why the other one was also incorrect. All right. So we still have 3, 5, 6 in the set. So we have 3, 5, 6 in the set. The one that has the least L value is 3. So we choose the 3 out of the set. We now only have 5 and 6 left in the set. So now we look into, okay, so what vertices go to vertex 3? 6, 1, 4, 2, 3, 2, 5, 4, 3, 5, 5, 3. So there's only a 5, 3 here, and I don't see anything else. So now the question is, did I just find a shorter path for vertex 5? So the answer to that question is to look into the L value of vertex 3 right now. It has a length of 2, and then we add to it the distance of 5 to 3, which is a 4. So we are adding 4 to 2, which is a 6. And then we ask, did we just find a shorter path? The current length of the shortest path from vertex 5 to a destination was a 6 already, so we did not find a shorter path. So that means there's nothing to process. We go back to the outer loop, and then now we ask between vertex 5 and vertex 6, do we need which one has the least L value? It is vertex 6. So we pick vertex 6 out of the set, get rid of it in the set queue, and then we look into incoming edges to vertex 6. 6, 1, 4, 2, 3, 2, 5, 4, 5, 3, 3, 4, 5, 6. So we have vertex 5 again here. So now we ask the question of what is the length of the shortest path from vertex 6 to a destination? It is a 4. And then we add this edge 5, 6, the distance of the edge 5, 6, which is a 1, to the 4. So we have 5. So this means we just found a shorter path from vertex 5 to a destination. The new length is going to be a 5. So now we do have some updates to do. We copy and paste the entire E prime. We add the new edge, which is 5, 6. And then we have to get rid of the current edge from vertex 5 to anything. So that would be the 5, 5, 4. So we take this part and then we do Alt Shift 5, strike it out, and then we have to add 5 back to the set, but it is already in the set. Are we good so far? Okay. So now we go back here. We only have one vertex left in Q, so it has to be the one with the least L value. So we take 5 out of the set. The set becomes empty. And then we look into incoming edges to vertex 5. There are no incoming edges to vertex 5 because we have 6, 1, 4, 2, 3, 2, 5, 4, 5, 3, 3, 4, and 5, 6. So there's nothing to do here. And as a result, the algorithm is done. So that's pretty much how the trace is supposed to go. And do we have any questions? There are no questions. Yep, go ahead. hmm hmm So if you, okay, so let's just, let's use an example, right? Let's say that, we are still considering 5, 6, 3, 5, and 6. So at that time, 3 had a 2, 5 had a 6, and then 6 had a value of 4. If you pick the wrong one, you can potentially end up not finding the shortest path. Yep. So it would be considered an incorrect step, but depending on how you consistently you choose the wrong one. So it depends on that, you know, when I give you a score. Yep. Any other questions? So let me just repeat the question and how it relates to the algorithm. So the question was, do we have to choose the specific um, the, the vertex with the smallest value? Okay, so that was the question. And if we go back to the module, okay, with Dijkstra's algorithm, which is up here, that's what this step is about. Okay, it's because we want to select a V from the set Q such that if you use any vertex in Q to compare to V, L of V has to be less than or equal to all of the vertices in Q, including itself. But it's okay because the L value of something is less than or equal to the L value of the same thing. All right. And this is also this part here, okay, what the mouse pointer is pointing to. This is also why the algorithm is called a greedy algorithm, because we are basically being super optimistic and choose the vertex that has the least value to begin with and go like, okay, this is probably the right way to do it, okay? But I can construct a path where it is, or I can construct a graph where it is by design defeating the greedy algorithm. So every time you choose, based on the greedy algorithm, it will actually choose the wrong thing, which basically triggers the algorithm to re-explore the same thing again at a later point. It still won't give you the wrong answer. Okay, it just kind of give you some extra steps. Yep. Hmm? Again, the spreadsheet. Oh, sure. And by the way, when you share with me, I need edit access, so make sure that you share with edit access. You can retroactively change it. Okay, I won't take any points off because with edit access, I can also look at the history, so I can basically say if anyone attempts to change the document after the due date and the time, I go like, well, I cannot count that in because those edits are after the due date. But you all have access to this spreadsheet now, the one that is dated with today's date or named with today's date. So now you can, use this one, and annotate it, okay? Annotate it, relate it back to the algorithm, and also you try to explain how each step of the algorithm works, because that really is the main point of the homework assignment. Yes, the last step? Sure. All right. So since I talked about how to use I am going to ask AI to give me maybe a more interesting example, so I can kind of practice this a little bit more and also to kind of look into trickier situations. So this is how I will prompt AI. So now we go to Gemini, okay, and go back to the same conversation. This is the same conversation. So I'm going to say, can you, for practice purposes, give me a graph such that the L value of a vertex is updated many times, as many times as possible. Okay. But I might want to give it some constraints because otherwise it might give me a graph that has 100 vertices. I don't want to deal with that kind of chore. So we can limit, okay? We can say limit, okay, limit the number of vertices to 6, okay, which is the same as our example. In terms of the edges, you can also kind of customize and go like, okay, how many edges do you want it to have? So let's just say that I don't, give it that kind of restriction, and this is the entire prompt. Okay, so I'm curious as to what kind of a graph it's going to give me, and you can also use this as a way to practice. It's actually thinking the way that I would do, which is using inequalities to determine, what values to use for all the distances of the edges. And then later on, you can ask what strategy it used in order to create a graph like that. All right, so we have the D's, okay? So, edge 2, 1 has a weight of 1, edge 3, 1 has a weight of 2. So it is a larger graph compared to your homework assignment, but let's go ahead and take a look at this one. I have to shrink a little bit because I want to show you what the graph looks like, okay? And then we'll see why this one is a little bit tricky. All right, so we have, does it say which one is the destination is 1? Okay, cool. All right, so we have vertex 1, and then we have vertex 2, 3, 4, 5, 6, all going to the same vertex. So you can probably see the strategy that AI is using right now. Okay, so all of these go to vertex 1. They all have a direct edge to vertex 1, and the distances of the edges are 1, 1, 1. They're all ones. Okay, so we have 1, 1, 1, 1, and 1. Okay, so we're done with those, and now we go to vertex 2. So vertex 6 also goes to vertex 2 with a weight of 15. So 6 goes to 2 with a weight of 15. And then we have 6 to 3 with 10. So 6 goes to 3 with a weight of 10. And then we have 6, 4 being 5. So 6, 4 is a 5. And then we have 6, 5 with a 1. Okay, there we go. There's a 1 here. All right. Yep. Oh, so the weight from 6 to 1 is 6, 1 is 20. Oh, okay, you're correct. 6, 1 is 20, and then 6, 3 is, oh, okay, got it. So this one is 20. Okay, that makes a lot more sense. Thank you. Okay, there we go. All right. So without running the actual algorithm, which vertex is going to have its L value updated the most number of times. Just looking at the graph here. So vertex 1, mm, mm, no, it's not. Let me see. It's not vertex 1, it's vertex 6. Vertex 1 gets its L value exactly once from the initialization because it is a 0. Yep. Vertex 6, on the other hand, gets it updated how many times? It will get a 20, and then then it will expand all of these. And then once it expands to all of these, then it can randomly pick one, which means, depending on how random that thing is, it can be not a whole lot of times, or it can be many, many times. So it depends on, when you look at the incoming edges to, mm, no, this is correct. Oh, okay. So now you have to choose, all of these, and which one you choose first actually determines, how many times we might end up updating the L value of 6. So let me repeat that, to you. So if you choose to expand 2 first, because all of these have the same L value of 1, so that means you could have chosen 2, 3, 4, 5, any one of these when you look into um, which one to expand first from the set of Q, because they're all going to be in the set of Q with an L value of 1. If you expand the one that actually is the shortest path, which is vertex 5, then vertex 6 will only have the L value updated exactly once. It will get, well, okay, if you count in the initialization, it would have 3 updates or 3 cells, because the initialization will update it to be infinity. The first value is going to be 20, and then the second value is going to be 2, and it is done. Do you see what I mean by that? Okay. So now that you understand that, this is not guaranteeing that we are going to update the L value of 6 exactly as many times as it takes, because it depends on which one we choose to expand from the set Q. So now I can, kind of report that and ask it to say, okay, fix this so that we are forcing the update. Okay. So now we can go back here and then we can say, but this configuration um, may update L of 6 only twice, not counting the initialization. The reason has to do with choosing vertices 2, 3, 4, 5 from the set. So we are looking at 2, 3, 4, 5. Hmm. Hmm? Right. Uh, oh, okay. I did not. I copied that incorrectly. Okay, so with all of that, yes. Thank you. Now it's ordered. Now we have a specific order. Okay, I did not copy that. So that's a 2, that's a 3, that's a 4, and then a 20. Okay, so now it is definitely updating exactly how many times? It's going to be 20 first, and then it will be 16, 12, 8, and then finally a 5. So that's the order of the updates. Hmm? L, what do you think? It is in the algorithm. So we can go back to the module. I cannot remember. There we go. It is length. Yep. Hmm. It's the length of the shortest known path at any point of the execution of the algorithm. Q. So are you talking about the name of the set or are you talking about the membership of the set? Say again? It's just I think I picked it up from an algorithm. It used Q and I just kind of I stick with Q. So there's no particular reason why it's Q. Yeah. All right. So, but are we understanding how to use AI to generate more chances or more opportunities to practice? Okay. So let's just say that for some reason you think, okay, I'm a little bit sick and tired of, having the AI to keep asking me questions and not giving me the answer. If it is your gem, you can always go back and change your gem so that it doesn't do that annoying thing. So you can go back to your gem, okay, go to edit, and just remove the whole instruction thing, or remove at least enough of it so it doesn't give you um, all the questions. So you can basically just take out the prioritize scaffolding. Okay, then it won't try to structure the instruction in terms of scaffolding, but I think it is actually helpful in this case. So if you want to kind of experiment with different things, you can actually duplicate your gem. Okay, so if you go back to the previous screen and you go to your gem, I think there's an option to duplicate the gem so that you can actually change one but not the other one. Make a copy. So now with this copy, you can now change it so that it does not give you the annoying, instructions. Okay, so I have to be careful which part to neuter. All right, so let's go ahead and look at each item and see why each item is useful. I think I just do double the whole thing. Yep, I did. So I think I just duplicated the whole thing down here. There we go. Oh, actually, I did not. Okay. Okay, I think I messed up somewhere here, but the main points are still active. All right. So the first point is okay. The description is really important because if you don't describe the role of the AI, of the gem, then it won't understand that it is acting as a tutor. So it will try to give you the most straightforward answer as possible, which means it's not gonna be able to try to identify what you're not understanding and try to help you understand what you're not understanding. Okay, so that's why it is important to define the role of the gem. So in this case, I try to make it as specific as possible. It is a tutor and a mentor in the setting of a community college course. And the main goal is to guide the student, which is the user, to understand concept and solve problems on their own and not to give them direct answers. So if you take this out, okay, if you take out this portion and take out to prioritize scaffolding, then it won't give you the scaffolding type of questions, which can be annoying to some people, okay, but for some other people who are really trying to understand the concepts, they're really important. Is this term understood what it means in the context of the AI? Scaffolding in the context of learning? Nope. Okay, well, let's go explore that. So we look up, we can use Gemini again. Just open a new terminal, right? Okay, explain what scaffolding means in education. Okay, so scaffolding is a term that is particularly useful in higher ed, which you're in. It has to do with building concepts on things that you have already understood. And knowing what scaffolding means is really important if you want to make the best use of AI, because once you understand that term, then you can tell the AI to make use of this particular technique when you want to um, when you want the AI to help you understand. something. In education, scaffolding refers to the temporary support provided by a teacher that helps students perform a task they cannot yet do independently. So, and there's further explanation. The term is a direct metaphor from construction, just as scaffolding provides a temporary platform for workers to reach higher levels of a building. Educational scaffolding provides a temporary framework for students to reach higher level of understanding. So, and so on and so forth. But it's a technique, okay? It's a very important keyword because the LLM, the large language model, actually understands the definition of scaffolding in this context. So by mentioning scaffolding, you are now telling the tool, the AI, how to interact with you so that it will first try to assess how much you understand already, and then it will try to kind of build on top of what you already understand, as opposed to we'll just start with how tech is presenting the material, because most people find my material to be a little bit too concise and not enough examples. So the AI is here to kind of help remedy that. Is that okay? Does that help you? Okay, very good. So now we can go back to the other items. Okay, so we can go back to some of the other items. Analyze and assess. Okay, so this is mine. Okay, these are many of these statements are my statements. When a student asks a question or provide an incorrect answer, first analyze their input to understand their current thinking and where they're stuck. So that means if I give a wrong answer to the AI scaffolding question, it won't just tell me the correct answer right away, and instead, it will use its own ability to try to analyze where the misunderstanding is. Okay, so, and then we can use probing questions, respond with questions that prompt the user to think critically and break down the problem. So that's also important. So anyway, I can make this available to all of you. So if you want to apply this to your other classes, you're free to do so. Um, if you don't find it useful, okay, don't easy, okay, don't use it, okay. But I'm not. I think it is important that you guys know how to use the tool because that is the future, okay. Understanding how to interact with the AI in a in a way like this, okay, is really important because it helps you solve the problem at this point, but it also helps you understand how to use AI in your future because you are going to be required to use AI. Okay, let's digest that particular statement. I said you will be required to use AI. So in what context am I talking about? In your English class? In a history class? In a political science class? No, I am talking about your employment. Okay? And you guys would go like, really? My future employer actually expects me to know how to use AI? The answer is yes. Okay? With Microsoft, um, and a few other really large employers, they already basically tell their employees, if you don't use AI, we really don't want you to work here. And why is that? Sorry? It's because they want to get the most money out of your salary. Yes, yes. So they want you to understand how to use AI to streamline what you do so that your employer gets the most bang out of the buck in the form of your salary. Okay? So that's why they say if people refuse to use AI, they would actually fire people over that, which is the opposite message compared to what you might have heard at this level of education, which is if you use AI, I will report that to your dean, to the dean, and I won't count your homework assignment. So you just have to reconcile between the differences, but understand that in the long run, as a computer science student, you need to know how to use AI. And what I have demonstrated here is only the tip of the iceberg of how you can really utilize AI for production. okay, for productive ways in a productive way. And it's not just giving you the answer, it's helping you learn in the process. And one more thing, I know we are getting close to 440, 420. AI or the GPT understands enough about itself to the point that you can ask questions like, how can I best utilize Gemini in my education? You can actually ask questions like that and it will give you a reasonable answer. So, I would encourage you to play with all of these prompts, okay? Because that is the future. You have 2 more years, okay? Assuming you graduate this semester, which most people do, okay? Some may have one more semester. You have 2 more years at a 4-year university, and then you're out there, okay? Looking for a job. So that means you have 2 more years to really hone your skills of how to use AI in a productive way, to figure out what it can do, what it cannot do. Okay. So by the time you are out there, you can demonstrate, okay, what you can do with AI. So there is a lot of people comparing the two. I think they're comparable at this point. So if you're looking at Gemini 3.0 versus ChatGPT 5.1, I think they are considered to be fairly comparable. Some people prefer answers in one way, some people prefer in the other way. I use both, and I don't really see a clear difference of which one is better. Yes, so it has convenience. So for instance, for all the knowledge stuff that you need to do, okay, so let me scroll back down to the knowledge area. You can click the plus and you can add from the drive. So that's a huge plus because now you can use a Google Doc to hold all the knowledge and you update the document without having to update the gem itself. Actually, it is the opposite. Okay, so let me address your question before coming back. Go ahead. Oh, okay. So let me finish this topic and then we'll go back to Dijkstra's. So, ChatGPT, people have found that ChatGPT actually uses Google to answer some of the questions because when Google did a security sweep of what kind of prompt or what kind of uh, search query they're getting, they are getting basically queries from ChatGPT. So ChatGPT would use Google to get the answer and then relay it back to the end user. And you cannot ask uh, Gemini to read an article for you. You actually have to copy and paste it. It won't go out there to look at copyrighted content or not copyrighted content. You have to copy and paste it. But ChatGPT will be more than happy to do it for you. Yes, go ahead. About Dicegrass applications. Hmm? Hmm. It will find the shortest path if the edges or the distance of the edges are known. It will find the shortest path. So if your video game involves finding the shortest path, it probably is either using Dijkstra's algorithm or the A star algorithm. Depending on whether A star can significantly speed up using a heuristic, but Dijkstra's algorithm is definitely easier to implement. It only finds the shortest path. The classic Dijkstra's algorithm can only handle one starting point and one destination. The modified Dijkstra's algorithm will find all the shortest paths from every single vertex to the closest destination. You can have many destinations. it's just point to point for the most part. It is point to point. So if you're playing a video game and you need to find the shortest path between 2 points in the game, then Dijkstra's algorithm or the A star algorithm will both be applicable. But it is not optimizing in terms of, if okay, let's just say you're playing League of Legends and you're trying to build your items and so on and so forth, and you have a certain, income because of because of the game. So Dijkstra's algorithm would not be very useful for that because it doesn't understand the interaction between the items. And neither can it take that into consideration because it's not a linear path anymore because you're building the items in parallel, and that is not a linear path. Yeah, yep. And when you're building to the ultimate, so it cannot give you the optimal path to upgrade your items to the end. Yep. Yeah, and also because of a gameplay, it is dynamic, so it depends on what the other team is doing. So that's why it's not something static like Dijkstra's algorithm on its own can handle. You can probably look into the game situation and change the weights accordingly, and then as a result, it might be able to give you a suggestion of what to do next. Yep. All right. So we are done with today's class. On Wednesday, we are going to start a new topic, and I'll let you guys choose what to do because we can do predicate logic or we can go back to time complexity. It is the same thing as predicate calculus, and we're going to use Prolog for that. It's going to be fun. It's a programming language on its own. It can figure out things on its own too. So, and that is interesting from today's perspective as well, because that was what AI used to be. Predicate calculus was quote unquote AI about 30, 40 years ago. Yep, and that has changed. It is interesting. hmm there are two tuples. There are two tuples where both items in a two tuple are vertices, because all it wants to do is to tell you from which vertex to which other vertex. Uh, Well, if your map is spatial, then yes. So each vertex is going to be an XY coordinate. Yes, it'll be like like a true graph, but in 3D space it will be XYZ, right? Yep. But in that case, you also need to look at the connectivity between the vertices because if you're looking at a maze, okay, it's not always the case that you can go from one vertex to another vertex because of a wall. So now you have to remove the edges because those do not exist. Yep. So I think the quick giveaway is this, right? Yep. So that looks good to me. Yep. Like a